This is the second derivative. Well, earlier, the first derivative was not bad. You just divide by the first derivative and the first derivative with respect to t's. Maybe I will just have to differentiate this again, so I get d2x, dt2, and I'm going to explain the notation why it's a 2 here and 2 here. But anyway, let me just do the derivatives. Differentiate this again, I get 2, and then differentiate this again, I put down d2y, dt2. Derivative of 1 with respect to t is 0. So this is what we have. Well, can I just say d2y over dx2 to be the second derivative here divided by the second derivative here, meaning can I just do d2y over dt2 divided by d2x divided by dt2 like that. On the top, I will put down the 0 for the d2y dt2. On the bottom, I will put down the 2 for the d2x dt2. 0. So, if you do that, you are saying the second derivative at this point is 0. Cannot be the case. Look at the graph and look at this. Not possible. Not possible. Not possible. Why not? Because this right here, this part of the graph, is concave down. So what does this mean? This will tell me that the second derivative, d2y dx2, should be less than 0. The second derivative has to be less than 0 in order to get a concave down right here, right? And in fact, you could also tell this is wrong because you see the dt2 right here. If you cancel them, on the top you get d2y divided by d2x. The notation is not the same as this. But either way, this right here, unfortunately, it's not as easy as the first derivative. Please get this out of the way. Don't ever do that. Okay? Don't ever do that. Let me just cross this 0 out again. It's no good. Alright, so now let's talk about this legitimately. How exactly can we do this? In order for me to do so, I will have to play around with the notation. And this is the time that I will really take the time to introduce the notation. First of all, let me just write down, here is my first derivative, namely dy dx. No problem on that. What does this mean? This is simple. You are just pretty much doing that. You differentiate the y with respect to x. And let me put this down. I differentiate, so we have the d dx, and I'm looking at the y right here, like that. And that's pretty much it. And this time, let's focus on this y in red. And we're talking about parametric equations. So let's look back to what we did here. We had this formula. And this is the connection between dy dx and dy dt and dx dt. And check this out. Y here, y here. And for this right here, we are saying we're differentiating y with respect to time. And let me put this down. When we have the dy dx, I'm going to write this down right here. It's the same formula, but I will put it down as d dt of y like this. Okay? Same thing, okay? And then for the denominator, I will divide this by right here. We have the dx dt, and this is pretty much it. Now, moving on to the second derivative, the d2y dx2, I will put it here. And here, as you can see, we are talking about this kind of second derivative. Well, if you look back to here, what did this mean? In fact, when you are differentiating with respect to t, you can just think about acceleration in the second derivative right here. So the acceleration in the x direction is 2, and the acceleration in the y direction is 0. That's pretty much it. This tells you when you go upward, right, you have the same speed all the time. There's no acceleration. But if you are going along the x direction, there is the acceleration, meaning you are going faster, all that. Anyway, so this and this, they are very different. This is the concavity of the curve right there. If you would like, you can just differentiate this with respect to x. I'll leave that to you, and we can see the answer right here. But let's see. Here is the explanation of this notation, why we have the 2 here and the 2 here. Well, how do we get the second derivative? We differentiate the first derivative, don't we? Well, so right here, we are saying we are differentiating the first derivative, and the first derivative is, of course, dy dx, like this. And you see, on the top, we have d and d, so of course, you can put a d2 right here. On the bottom, we have dx dx, so that's why we have the dx2 right there. And you might be wondering, shouldn't we put the little parentheses like this and then like that? Kind of, but nobody does it, so don't do it. So this right here, it's pretty much the notation where we have the 2's like this. And now here's the beauty, why I took all the time to do all that. d dx, input, input go here, input will go here as well. Meaning you have to differentiate with respect to time of the dy dx. And then you divide it by the dx dt when you are working with parametric equations. You put the first derivative right here, you put whatever you want right here pretty much, and you are differentiating this with respect to time. This right here makes sense because as you saw earlier, dy dx in the parametric equation world was in terms of t. So in fact, in order for me to do this, I will be putting this right here, meaning I will have to differentiate this with respect to t. So let me do that for you guys. To continue, we see that on the top, I will have to differentiate my first derivative in terms of t, which is this that we got earlier, which is 1 over 2t minus 2. And then, in the denominator, we have to divide it by the expression that we had, namely the dx dt. On the top is calculus, on the bottom is you put this down and divide it again. So, let me just do the derivative real quick on the side. Alright, so I will just put this expression down and we have negative 2 on the top over, this is parentheses 2t minus 2 to the second power. And yes, you can factor out a 2 and then cancel the 2's, but let me not do that because I think this is actually prettier. And you'll see in the denominator, dx dt is 2t minus 2. So I'll just put down 2t minus 2. So you see this and that is the same thing. So you can bring this down and join this denominator. So to clean this up, this is an okay expression. It's not the best, I know, because you can seriously somehow cancel the 2, but as I said, let me not do that. Anyway, when you bring this 2 down, it's actually with the 1, so it's the third power here. Alright, so this is an expression for the d2y dx2 in terms of t. And then you plug in t is 4. Go ahead and do your work everything out, reduce your fraction, you get negative 1 over 108, like this. And we are done. So, right here, if you differentiate this again with respect to x and then plug in 8 for the x value, you also get this right here. Okay, so hopefully you guys all like this video. If you have any questions, leave a comment down below and let me know. Thank you guys so much.